We're going to look at the first section in Chapter 3. This is pretty much what we did in class. And we'll start out with the definition of functions. So if you want, for extra emphasis, you can capitalize FUN for fun. These are kind of fun. At least you can pretend they might be. Definition of a function is a relationship between two sets. One's going to be your input, and that's usually called the domain. We usually use the variable x, and the other one is the output, and that's usually called a range or the y. Where each input x has exactly one output y. So one input, one output. Very briefly, if we do a short example and we look at these two sets, one in white here and then one in yellow here, we're going to make the distinguish between what's a function and what's not a function. The first one is I look at the inputs. My inputs for the first one are 1, -3, 4, and 3. So I don't have to worry about repeating of the inputs. So I don't have inputs repeated. So this is going to be a function. Every input has exactly one output. The second one actually has a problem. You have 1 and 1 listed twice in the x coordinate, and so that's going to be a problem for us because x is going to be, when x is 1, we get two outputs. We get 2 and 3. So this is not a function because the input of 1 gives us two outputs. Now if we look at the next one, y equals 3x plus 2 is a function. And why I say that is because we can plug in whatever we want in for the x, and we're only going to get one answer out. So if I plug in like 1, 3 times 1 plus 2 is 5. So this is a function. Whatever I plug in, I'm only going to get one answer out. The other one here we've seen quite a bit of recently is this x equals y squared, and I'm going to say it's not a function. And since it's not solved for y, we're going to go ahead and solve for y. And when we solve for y, we undo the square by square rooting, and we get plus and minus. If I give an input, which is the x, of 4, I'm going to get two outputs. I'm going to get plus and minus 2. The 2 comes from the square root of 4 is 2. Plus and minus was there when we took the square root. So if the equation is not solved for y, go ahead and solve it for y. And look for plus and minus. If you have plus or minus, probably not a function. And also look for y to the n where n is even, because then you'd have a square root or fourth root or sixth root. When you do those even roots, you're going to get plus and minus. The domain of a function is going to be the set of all acceptable inputs. So things that would not be acceptable inputs are where if I plug it in, I end up dividing by 0, or I plug something in and I get square root of imaginary number. So we're going to keep it real for the most part, so no complex numbers. So when you're finding the domain, your default is it's going to be all real numbers. But a lot of times we're going to ask you questions where you have things that you need to watch out for, like the denominator equaling to 0 or a square root. So if you don't see a denominator or you don't see a square root, then it's all reals. And how we handle this is we'll set the denominator not equal to 0, and that'll give us some values where x cannot equal. For the square root, the thing underneath the square root, the fancy word for it is called the radicand, and ensure that we don't take square roots of negatives. We set the radicand greater than or equal to 0. So no division by 0, no complex numbers. And let's scroll back. So let's do some examples of finding the domain. So we're going to do 1 over x minus 1. Can't be all real numbers because it has a denominator, and I'm not going to be able to plug 1 in. So we set the denominator not equal to 0. Add 1 to both sides, and we get x cannot be 1. So you have a couple of different ways of saying that. You could say that it's all real numbers except for 1. You could do the interval notation. If you're going to do the interval notation, you might want to help yourself out by drawing a graph here. So it's going to be everything except for 1, So it'd be negative infinity all the way to 1. The u in between them is union. It means or, so we're either on the left of 1 or the right of 1. And I might ask for interval notation, so you should know how to do that. So let's do another example, and that's the domain x cannot be 1, or that interval there. So what if I asked you about g of x equals x squared plus 11x plus 12? Well, I'm looking for denominators and I'm looking for square roots. I don't see any denominators, and I don't see any square roots. So, no denominator, no square root. It's going to be no problem. Our default answer is it's going to be, the domain is going to be all real numbers. So everything is going to be okay. So negative infinity to infinity. And go ahead and write over there on the left what the domain is again for the other example. Oops, it shouldn't be 0. What should it be over here? It should be 1. Domain is everybody except for 1 in this previous example. So that would be one way you could write it. You don't have to spell out 1, and you could just write the number 1. Okay, I think I got 2 more of these. So let's say we want to find the domain of h of x equals the square root of x minus 4. No denominator, but we do have a square root, and we got to set the radicand greater than or equal to 0. The radicand is x minus 4. So x minus 4 needs to be greater than or equal to 0. We add 4 to both sides, and in interval notation that'll be 4 to infinity. If we give you another one, this k of x function, this is the best of both worlds, in a matter of speaking, because we have a square root and we have division. Well, we got a denominator there, so we got to do 2 things. The denominator can't be 0, and the radicand has to be greater than or equal to 0. The first one, to undo the square root, we got a square, so we're going to square both sides, and then subtract 5 from both sides, and I need to add in my negative there. And on the other one, the inequality, we're going to subtract 5 from both sides. Oops, and put in my negative. Okay, so now we have two conditions here. It can't be equal to 5, and it has to be greater than or equal to 5. One says we can't be equal to 5, and the other one says we have to be greater than or equal to. So we can't have the equal to part in the or equal to. So we just go with the strict inequality, x is greater than negative 5. Let me put that negative in there. Here we go. So our domain is negative 5 to infinity. The last part of 3.1 has us looking at function operations, so the sum, the difference, the product, and the quotient. So the sum says if we have f plus g of x, so f plus g of x, how that's defined is f of x plus g of x. So we just add the 2 functions, whatever they may be. The difference is very similar. F minus g of x is just f of x minus g of x. F times g of x is equal to f of x times g of x. F divided by g of x is f of x divided by g of x. Then we got to be a little bit careful. We don't want to divide by 0, so we make the restriction that g of x is not 0. And if you're asked to find the domain is going to be the intersection or the overlap of the domains of f and g. Or you can just find the formula for whatever the sum, difference, product, or sum, and then just find the domain like we did on the previous problems, because it'll end up looking something like that. So let's look at 2 functions. So let's say we're given f of x is 2x plus 5 and g of x is x squared plus 2, and we're asked to find f of 2. So what this means is evaluate the function at 2. It's just very nice shorthand notation. Also, because we're using the letter f kind of stands for function, so we're kind of told that it's a function by how it's written. The f function takes input, which is the x, multiplies it by 2, and adds 5. So if we give it a 2, we're going to multiply the 2 by 2 and then add 5. And we'll get 9. Now if we feed 2 to g, g is going to square its input, so it's going to square 2 and then it adds 2 to it. So we're going to square input and then add 2. We're going to feed it 2, so 2 squared is 4 plus 2 is 6. Now I can do the same thing with variables. If I say I want to find f of h, that just means replace the x with an h. X just stands for your input, so what I plug in the parentheses here, that's what my input is. So replace your x with your input. So it's just 2h plus 2. And we can do the same thing with happy face. G of happy face. G function squares your happy face, so I don't know if that changes it into a square face. I don't know. I haven't looked into it yet. So you get happy face squared plus 2. What if I asked you to find f plus g of x? Well, that just means add the two functions. So f plus g of x would be 2x plus 5 plus g of x is x squared plus 2, and combine like terms, x squared plus 2x. And our like terms were the 5 and the 7. Okay. So let's look at another example here. So let's say we're given the same functions, and we're going to do a couple more sums, difference, and quotients and that kind of stuff. So let's find f plus g of -1. So that means f of -1 plus g of -1. So what we need to do is we need to plug -1 into the f function and -1 into the g function, find what that is, and add them. So plug into the f function and then into the g function, and we end up with a nice answer of 6. Okay, so it's not terribly difficult. That you just got to be careful what you're doing. F times g of 0. It means f of 0 times g of 0. So we're going to plug 0 into f and find an answer, and we're going to plug an answer into g and find our answer, and we're going to take those two answers and multiply them together. 2 times 0 plus 5, 2 squared plus 2. It'll be 5 times 2, which is 10. We'll do one more. We'll do a quotient here. We'll do f divided by g of 1. So that means f of 1 divided by g of 1. So we're going to go ahead and plug in 1 in for the f function and the g function, and then we're going to divide them. Okay, and we get 7/3 when we're all done with that. So not terribly difficult, just got to be a little bit careful. The last thing we're going to look at is called the difference quotient, and it looks mean and scary, but if you break it up into the 3 parts like we do, it's not so bad. It may take a little bit of practice, and if you end up taking pre-cal or calculus, you'll definitely see the difference quotient again. If this is the last math class you need, then it's just a college algebra problem. You have to know it for a little while, and then you don't have to worry about it afterwards. But if you plan on going on, you definitely need to know what the difference quotient is. So the difference quotient is, it's a lot like slope. The f's are your y's, so I have like a y2 minus y1 in the numerator, and then if I subtract x plus h and x, if I take their difference, I'm just left with h. So it's a lot like finding a slope. It's kind of like a slope of a secant. And so we're going to break it up into 3 steps. So I'm going to find the difference quotient of that same f function, 2x plus 5. So what we're going to do is we're going to break it up into 3 parts. We'll find f of x plus h. So your function takes input, it doubles it, and then adds 5. So if we're feeding it x plus h, we're going to double it, which means multiply it by 2. Then we're going to add 5. So we'll use the distributive property, and you get 2x plus 2h plus 5. If we want to find the next piece, the minus f of x, it's just going to change the sign. So it becomes negative 2x and a minus 5, and then we'll put it all together. F of x plus h minus f of x all over h, and we'll go ahead and replace. F of x plus h was 2x plus 2h plus 5, and the minus f of x, we found that was negative 2x minus 5, and the nice thing about this is we're going to be able to say so long to some folks, because we got 2x and negative 2x, those are going to cancel out. 5 and negative 5 are going to cancel out, so you're just left with 2h over h, and h divided by h is 1, so we're just left with 2. Okay, one more that's a bit more complicated, but it's going to be another difference quotient, and we're going to change the g function a little bit. So difference quotient with the g of x plus h minus g of x all over h. I'm going to change g of x to be x squared plus 3x plus 2. So first thing to do is find what g of x plus h is. So wherever you see an x, this is going to be replaced with an x plus h. Okay, so x plus h squared, that's your input squared, plus 3 times your input's x plus h, plus 2. Okay, we're going to have to multiply out the x plus h squared, so it's x plus h times x plus h. You're going to need to FOIL that. Plus, if we distribute the 3x plus 3h, and then plus, I forgot my plus 2. I think I do it again in yellow. So I'm going to put in that plus 2. I forgot it. When I FOIL the x plus h times x plus h, x times x is x squared, x times h is xh, h times x is xh. So I have an xh and an hx, that makes 2 xh's, and then h times h is h squared. So we're just FOILing, plus 3x plus 3h, and then I forgot the plus 2, so for extra emphasis, it is in yellow. And then the second step is we're going to find minus g of x, and we're just going to change the sign of everybody. It'll be negative x squared minus 3x minus 2. And step 3 is just putting it all together. G of x plus h minus g of x all over h. Okay, so right now we're writing g of x plus h, that big long thing underlined in yellow there. So we just replace that. And then in this kind of pinkish purple, I don't know how we want to describe it, we're going to replace negative g of x with minus x squared minus 3x minus 2 all over h, and then we get to say so long to a bunch of folks here. We'll say goodbye to x squared, we'll say goodbye to the 3x, and we'll say goodbye to 2 because we have a positive and negative version in there. So what's left is 2xh plus an h squared plus 3h all over h. And then we're going to go ahead and factor out the greatest common factor in the numerator, which is an h. So when I factor out the h, we're left with a 2x, an h, and a 3, all over h. And we have like factors of h that will cancel out, and we're left with 2x plus h plus 3. So we did a whole bunch of work, and that's our answer. So later in calculus, this will be much more important. Same thing with pre-calculus. This will be an important idea.